the topic here is limits at infinity. So let's try to do example 2. This is the continuation of the previous examples. So limit as x go to infinity, same thing, we're going to divide by x squared because the denominator, the term with the highest degree is x squared, so we divide by the x squared. So this is limit 5x4 divided by x squared plus x divided by x squared minus 1 divided by x squared over 9 x squared over x squared minus 3x over x squared as x approach positive infinity. Same thing, we need to simplify. If we do that, we'll get the limit as x approach infinity. X squared goes with x squared. You'll have 5x squared over 1, which is just 5x squared, plus simplify x with x, we get 1 over x minus 1 over x squared over x squared with x squared, we get 9 minus x goes with x, we get 3 over x. Now we know that these goes to 0, so this is the same thing as the limit of 5 over 9 times x squared as x approach infinity. Now here it's always going to be either positive infinity or negative infinity. So how do we know? Is x large? If you square it, it's still going to be large positively. Multiplied by 5 over 9 is still a positive number, so it's still infinity, positive infinity, not negative. So let's do example 13, and the difference between example 13 and the example 12 is just this negative sign. So let's see how that sign will affect the limit. So the same way, this is the limit. We're going to divide by x squared minus 5x4 over x squared plus x over x squared minus 1 over x squared, everything over 9x squared over x squared minus 3x over x squared as x approach infinity. Simplifying the same way we did at the top, it's exactly the same function, the only difference is this negative sign. So this will be exactly limit of 5x squared plus 1 over x minus 1 over x squared over 9 minus 3 over x as x approach infinity. This goes to 0, this goes to 0, this goes to 0, so this is a limit. Well, don't forget the minus sign here. This is a limit of minus 5 over 9 times x squared as x approach infinity. Now here, the difference between example 12 and 13, as x get larger with positive values, this get larger, but you multiply it by negative, it's going to get larger with negative numbers, so this is equal to negative infinity. Right? Now, what affects the limit here when the degree of the numerator is bigger than the degree of the denominator, whether also this is even or odd. So that's why I did example 14. So let's do example 14. We're going to get an odd, and then you'll see. So here we go. So this is equal limit, divide by x squared, so minus 6x5 over x squared plus 2x over x squared minus 3 over x squared over 3x squared over x squared minus x over x squared plus 1 over x squared as x approach negative infinity. Simplifying, we get limit as x approach negative infinity. So we get minus 6x squared goes with x squared, you get x cubed plus x goes with x, we get 2 over x minus 3 over x squared, everything divided by x squared goes with x squared, you get 3 minus 1 over x squared plus 1 over x squared as x approaches negative infinity. We know this goes to 0, this goes to 0, this goes to 0, this goes to 0, meaning the limit, right? So this is equal limit of minus 6 over 3x cubed as x approaches negative infinity which is equal to limit minus 2x cubed as x approach negative infinity. Now as x approach negative infinity, because we have an odd exponent, x cubed is still negative, so this goes to negative infinity, right? But remember, it's kind of like a large number, negative multiplied by negative 2 is going to be positive, so this is going to go to positive infinity. In other words, negative infinity times negative number will be positive infinity. But of course, we're talking in terms of limits. And that's it for this example.